So, what I got with these, the first point I always say is logs to the rescue. Whenever we're talking about an x being up here, we're usually going to have logs come to the rescue. But it's not logs, it's going to be the ln's. So if I go ln on that side, don't you torment her. And then I go, then I often look at what we call log laws. I'm trying to put a little bit of an order on this, okay? Log laws. So what log law could apply to any of that?
Excellent.
And I was talking about a minute ago, it's like saying me, don't forget about me, put me to the front. I've had a chance to really think about what it is. The next thing's going to be div. And how do you differentiate in this case?
Do the divide thing.
Is it, what is it, d to?
The derivative. Oh, because we're doing
X.
Yeah.
And of course they could change the letters and be a pain in the butt and do all sorts of horrible things and make them M's and K's or Z's or whatever it was going to be. Hopefully not. I don't think so. So I could go the derivative of that side. Now the big thing is that's just a constant. So what happens when you differentiate x?
Oh, it's just ln.
Just becomes a 1. So it's actually ln 1 of ln4.
Oh, that's a little bit cheeky.
Yeah. So that's the part there that always worries me, that people go wrong and they do all sorts of weird things because they're not confident with it. So I want to differentiate a y, but it says x, so those who are confident will just go 1 on y dy dx. What do I do for people who aren't confident? You even think of it all now. Do you even know what I used to do? I say we want some extra y's. So maybe you never even took that in as a concept because you never needed it. Did you need that? So watch what's happening here. That says get the derivative of y, which is 1 on y.
And you're left with the y dx.
That's what y is. So for those who get stuck. So the answer is dy dx equals y ln 4. But we go a step further, which is substitution, because in the start we already knew that. So now you've got 4 to the x ln 4.
Wow.
And that's the derivative of 4 to the x. Now you knew it off by heart and said, I don't need that, I could have just gone, well, it's ln 4 to the x, yeah? But what happens when you go to this one? Logs come to the rescue. ln y equals ln of x to the sine x. Now can I use log laws? Ethan, can I use log laws and why? I can put that to the...
You can go to the front, right? Yeah.
Yeah. So I can go to ln of y equals sine x. And that's a bit of a weird looking term. Now what do I want to do? Differentiate, so that's dx.
Yeah, see now that's a bit weirder.
Yeah, now you get there's the u and there's the v, so if we ignore that for a moment, okay? So therefore you go v by u dash, derivative of sine is cos, and I go plus u
Sine x.
sine x, I'm going to switch over these in a minute, and the derivative of that,
Y of x.
yeah. Should I write here, for the sake of anyone watching, that's v u dash plus u v dash? So a lot of people will go u v dash plus v u dash, but I go v, yeah. So what's this one over here? 1 on y dy dx, same as what we did over there, but if you wanted to, you could put the y dy. And there's the question basically done. Look how yucky it becomes. So that's going to be y outside of all of that. Last step.
Sub.
So we've got x to the sine x, that side of that. Now, could you two now do that because they are quite different.